Hi and welcome to this Traefik meetup. Today I'm going to talk about a story of mine, which started last year when we had this cloud native community across the Nordics. Then we wanted to do, knowledge transfer and that kind of stuff, and then ended up using Traefik and a lot of other cool tech in order to make it easier for people to educate. So let me share my screen about that and then start the presentation. Cool. And I think you you should be able to see it now. Cool. Thanks for joining me today. So a little bit of background about myself. I'm well, I've been working with oh, I see now it says former Kubernetes approver and sub-project owner. It should be Kubernetes, as you might have guessed. So my journey started 4 or 5 years ago when I ported Kubernetes to Raspberry Pis, and then been doing a lot of different maintainer roles across the community, been speaking at multiple KubeCons, leading SIGs and work groups and stuff like that. And now at the moment, I'm actually studying at Aalto University in Finland, in Helsinki, the second year at my bachelor's studies. Then, besides this, I do a couple of other things while I work for WeWorks part-time mostly during the summers when I don't have school. And then especially before COVID, I ran a lot of these cloud native Nordics meetups, which is one of the topics for today, actually. How to do that. And also now that COVID has, is in everyday life, how can we kind of get around it with knowledge sharing, with meetups and with building communities in these ways. So that's a bit about me. So first thing I would like to do is to ask, are you an educator? So are you passionate about learning, teaching others, and actually seeing persons grow and step up their game in tech and in otherwise? At least that's what really excites me and what's been so great about the Kubernetes community for my part when doing SIG, maintainership and other such tasks, and then going from there to the local communities here in Finland, and sharing that knowledge, helping people understand, help them with their problems, and get them forward with all kinds of different in all kinds of different ways, in a community manner, obviously. So I saw this Chinese proverb. Some also say that I think it was Benjamin Franklin said it, but tell me and I forget, teach me and I remember, or involve me and I learn. And that's kind of the spirit for today. How can we involve in this COVID situation? How can we still involve people? How can we still teach them something, although we are remote? And how do we technically make that work is the topic of this presentation. So Cloud Native Nordics is this collaboration between different meetup groups. We have 13, I think. Maybe now there's maybe even more of these. And it started from myself doing the meetups in Finland, and then realizing that, hey, we all share, a lot of the same infrastructure. We all have the same challenges. We all kind of struggle with the same days of the same things of running meetups every 2 months, every 1 month, and coming up with novel ideas. So we started this on GitHub. Actually, it was pretty funny, where it was essentially meetups by pull request. So kind of GitOps and and running meetups at the same time. Sharing like knowledge about different speakers, sharing knowledge about what kind of event we had, and then we made a website together of this, and Slack channel and that kind of stuff. And at some point, people started doing workshops in Aarhus, I think, and I did one in Helsinki, and then I did one in Tampere. And the problem kind of arose that all of these were snowflakes. So like I at least my first attempt was something like, use gcloud, the CLI for Google Cloud, and make a bash script that runs n amount of times, and then execute some huge command, and then hopefully something will get right, and then kubectl applying somewhere between, and then a lot of just random bash hacks in order to get it up. And then when I had it up, it was like, yeah, nice. Now I'm not going to touch it. Now just people get their Kubernetes environment and do something. But that wasn't as good. So we started thinking, or I started thinking about how to make this common for this kind of group, because it's not only me, it's all of these awesome guys too. So how can we collaborate on this kind of thing? So the agenda, that's kind of the backstory. That's the context where this is coming from, where I'm coming from in this presentation. So now that you are thinking about running a workshop, so if you want to run a workshop, teach Kubernetes, teach cloud native, what do you do, and how and why, especially in this situation? So we're going to start with that. Then we go on to technical requirements. Then I introduce Workshop-ctl, which is workshops as CTL, CLI written in Go, fully open source, that I built for this. And it utilizes Traefik, it utilizes GitOps, which is from the title. And then there will be a live demo. I hope the demo gods are with me. And the DNS gods too, which we'll talk about later. And then some practicalities like the economics of this, because at least this iteration is running in the cloud using managed Kubernetes. And then what to think about when doing these, both in person and also maybe online. And yes, if you have any questions for me, please write them in the chat as you think about them. Then Patricia can read them out loud to me, and it's just fine to interrupt really whenever, because in that way we get a bit more two-way conversation, which I would really like to have. So I'm not just speaking and not knowing the audience as much. So when you have questions, please shoot them in the chat, and then I'll answer them. I'll go forwards, backwards in the presentation as needed, and can also show other things around this. So don't hesitate. Okay, so if you have been teaching cloud native the classical way, what you might have done is gather people in a room, say everybody should bring their laptops, then like download Minikube. You're all on the same Wi-Fi, so it breaks. Then half of the people have some enterprise laptops, which need some administrators access to do like install any software, and those that can install Minikube, then something will fail on machine resources, or virtualization kind of screws up, or something like that. And then you've spent just 2 hours on getting everybody on the same page, having kubectl access to their local Minikube clusters at best. So, and I've also been prey of this. So, so that's kind of the not kind of state of the art, not really, but kind of. Taking this all virtually is even harder, because now, like, you don't even see the people's screens. So how can you teach them downloading Minikube and then actually provide some good content for everybody? That's really even more. In any workshop, people are executing at different speeds, but it's harder to get the feeling for how fast are different people executing, how fast are they doing their tasks when they're remote. So if we just spend the first hour installing Minikube or kubeadm or something like that, I helped made kubeadm from scratch. So it's I know that there's good things and there's bad things, as with all tech. And then maybe one of the hardest problems here is actually if you have, if you figure out how to create clusters, pre-provisioned Kubernetes clusters for the attendants of your workshop, how do you make sure they actually have different environments, but they are still 95% similar? That is actually harder than it seems. So we can do better. And now I'm going to introduce Workshop-ctl, which is the tool that I built, and with inspiration and help from others, obviously. So here in this picture, you can see a Visual Studio Code instance. It's a server, Visual Studio Code server, which is running in a Kubernetes cluster. Actually in a pod. It is exposed to the user, so the user interfaces with this Visual Studio Code server just through the web browser. So they don't have to, if they don't have Visual Studio Code installed on the laptop, they don't even need to install it. They just go to, for example, in this case, cluster.0.01.workshops.fluxuslabs.com, or any domain of your liking. So they go there, they put in a password, which can be unique per attendee, or it can be shared for privately in a Slack channel or something like that. So not just anybody can mess around with each other's environments. The number in the beginning, if you spin up 50 different clusters, then you will have cluster 01 to cluster -15. And so every user has their own Visual Studio Code instance. They even have their own Kubernetes cluster as a whole. Then to the to the left here, there's pre-populated tutorials. So depending on what you're teaching that day, you probably don't want to have, the user or the attendee write every single line of YAML that they need to in other way. I mean, normally you would do something like, you use kubectl to generate something, or you just copy paste something from the Kubernetes website as a starter, or you use Helm or something like that, or you use some higher level thing which generates the Kubernetes YAMLs. That's what you would do in real life, and that's also what you're encouraged to do here. So you can help the attendee taking your participating in your workshop by providing tutorials in Markdown, in YAML, in whatever. You can even have solutions in there. So we had one task that the attendees would do, and they had the solution actually in front of them, but it was just base64 encoded. So if they could just look at it and find the right answer, but then they had to figure out that this is base64 encoded and just decode it. So that can be used for checking the answer. Then they have a cluster shell with kubectl, Docker, Helm, everything that they might need. You can also add more things in here if you have specific, like use higher level Kubernetes YAML tool X, or something like that. So the cluster shell, the kubectl, when you're using it, you have full access, root access to the whole cluster, and that means you can for sure break your cluster. But if you do, at least you don't break anyone else's. Then, as is like an extra feature, there's also, as this is a normal Visual Studio Code, just browser-based, we actually have Kubernetes syntax highlighting also. So like if the user types, what often happened in my workshops was, and for me when writing Kubernetes YAML too, it's like you mess up some of the white space indentations, by 1 or 2 spaces. You don't see it, and then everything fails. But the syntax highlighter actually is going to tell you that this is not acceptable at this. This key can't be at this context. So,
cool.
So that's all good.
Here's your sidekick. We have 2 questions that just came in. One is, do you have a GitHub or any Git integration?
I'm not sure exactly what. Let me think if I understand the question.
Alex F., if you want to tell us a little more about your question.
Yes. So what I guess is the question is like, can we reuse the stuff that is installed? Yeah. So okay. Yeah. These pre-populated tutorials actually are just a Git clone from somewhere at GitHub. So like you just put up all your materials at one place in one GitHub repo, in one subdirectory, and then you just say to workshop-ctl, clone this and put it in the user's workspace. So if that's what you mean. And then there's also but there's also other things in GitHub integration, because like there's GitOps, which I'll come to later. There's GitOps of the whole cluster. So like you can actually go to GitHub where we have this manifest repo and just change some values there and just send a pull request, and then it applies. So that's cool. And then there's a third GitHub integration also, which is more like for chart reuse. So I don't want to say that I want to show like how to do Prometheus monitoring for the users, the attendees. Then nobody has the time to like, because the Kubernetes Prometheus chart with all the Prometheus things is like probably 2,000 lines of YAML. So I don't have time to hand write that, and it changes all the time. So that's where we have also like integration with GitHub, or with yeah, you could say with GitHub, with Git repos, more technically correct, so that you can actually download using Helm from the different places, and then just patch the small delta that you need.
And someone mentioned, I think we can commit from this IDE pod to Git.
Oh, right. It is, well, that is a perfect next idea. I hadn't thought of that, but that could actually be a really great thing. At the moment, the tutorials here, the workspace content here is just like a normal developer's file system. So it's not connected directly to Git in any way. But that is actually, yeah, that's That's a great suggestion, that you could have just git push, and from there, also from the user's perspective, include the GitOps part.
Great. And then there's one more, and then we'll probably want to be very mindful of time because it's going quickly. Are these remote developer environments similar to what coder.com offers?
So yes, so this is actually using the coder code server Visual Studio Code project. I don't know how to coder code. But yes, so the Visual Studio Code that you see here is using the coder.com's open source project. So yes, it's similar. I don't know exactly what they have as their enterprise solutions, but this is really specifically targeted at running workshops, running 50 different environments at the same time. So I kind of talked about this already. So everybody gets their own cloud managed or cloud hosted Kubernetes cluster. Cloud managed just makes it easier. I mean, I can spin it up and down in minutes, or at least hours. If they break their own cluster, it's their problem. They don't influence anybody else's. You can freely choose your domain, and with this we actually get an intuitive experience. So the solution, the Workshop-ctl, what does it need to have? It should scale for many different environments. So like we actually have, say we have 50 different environments, and then we have 2 tiers of the workshop. So like half of the people are experts and half of the people are beginners. Then it should scale so that we can actually have 25 of the clusters for beginners and 25 for the experts. But still reusing most of the configuration. And as I said, we can reuse off-the-shelf Helm charts, which greatly reduces the amount of code you need as a workshop organizer to write. It should be resilient, parallelized, and automated. This comes from the bash thing that I was talking about in the beginning. It was neither resilient, paralleled, and partially automated. So this and it failed because of some we're on a Wi-Fi, and then it you had bad network access, and boom, all of you're screwed. And it should be both developer and attendee friendly. So we're talking about the attendee part. You should just literally have to click on a link. Go to this. You get the link by email or something, and then one password to input. And then there is for the dev, it should be easy to use, like a kubectl or something inspired, and then it should be declarative, and most importantly, maybe it should be deterministic. So like if I run this workshop-ctl apply command, then I know what happens, for example. So where does all of the tech come in? So what do I use? So we have Traefik. Obviously, as this is a Traefik meetup, I had actually to include both logos because I think this is the current one, but I think this is so cute. Then GitOps Toolkit. I'll come to that later. So GitOps Toolkit is essentially the nickname for Flux v2, which is in CNCF. And then external-dns is an agent which syncs DNS records from Ingress objects in your cluster to a DNS provider, for example, DigitalOcean. Then Code Server is a coder.com open source project, which is the server-side rendering component of Visual Studio Code. And then Helm, very nice for not having to reinvent the wheel all the time. And then obviously Kubernetes. So now, and yeah, I should probably have said that in the beginning. This assumes that you have Kubernetes knowledge from before. I won't go into all of the things, like how what a pod is and stuff like that. But yeah, so this is the architecture diagram of the internals of this solution. So now this is one cluster, and then you should think that there's 50 of these just in different boxes. So let's start from the user's path when accessing the thing from the internet. We reach a load balancer in DigitalOcean. It has a public IPv4 that goes straight to Traefik. So this is a service in Kubernetes, and it uses a cloud provider integration in Kubernetes to do this. And that points to Traefik. So Traefik is the load balancer of the cluster. Every time Traefik sees a new request, or every time it sees a new backend, which is an ingress. So ingress rules in Kubernetes specify that what is the publicly facing domain, how do the users get into the cluster, and which services do they point to. And then, so yeah, Traefik listens to these ingresses and checks that, okay, I should have the @ here is the root domain. So like, for example, cluster1.kubernetesfinland.com or something like that. So if you go to cluster1.kubernetesfinland.com, you're going to go this way. You're going to go, Traefik is going to redirect you as per the ingress rule to code server. But if you put in Traefik in the beginning, traefik.cluster1.kubernetesfinland, then you're actually getting to its own UI. And then I have a sample application podinfo created by Stefan Prodan, one of my coworkers at Weaveworks. So that's a sample application of like, it can scale, and it's a really good microservices demo. So these are the ingresses that comes by default. And when external DNS is running in the cluster, it also looks at these ingresses and creates corresponding DNS records in the DigitalOcean domains side. And whenever Traefik sees these ingresses, it's going to create using Let's Encrypt. It will use the DNS 01 challenge and create TXT records here in order to prove that it owns the domain. And then it gets back to itself. It gets back Let's Encrypt signed HTTPS certificate, so that the communication between the code server and the user is completely encrypted using HTTPS. And then on top of that, when the user accesses a code server, they need to write the password in order to prove that they're authorized. And the same for Traefik. Before accessing the Traefik UI and API, they need to prove that they are authorized by inputting a password. So there's a lot of DNS here, which is really the key to creating all of these different domains and all of these different environments. There's these ingresses, pretty important ones, and also when the user creates their, so if one of the exercises is create a Node.js server and expose it to the world with given parameters, then they can just create an ingress and automatically make it point to their desired service. And then the domains will be created automatically. The HTTPS will be handled automatically, and everything is just automated. And we never use more than one load balancer in DigitalOcean. So we don't have to pay more than 10 euros a month for this. And then this is all running in one droplet. Obviously, if you're running something really, really, really heavy, then you might have to have two. But there's this one droplet per cluster, and then n clusters, maybe 50. So why do we use Traefik? I touched upon these already, but we only need to pay for one cloud load balancer. I mean, the other way of doing it would be to make all of these n different. Now they are 4 here or 3. All of the different ingresses have their own load balancers in DigitalOcean, but that would cost more and actually not give us that much, because then we don't get the automatic HTTPS and all of that. So it's actually better this way and even cheaper, because Traefik has the Let's Encrypt integration. And just like plug and play experience with Kubernetes. So we just create an ingress object and boom, it's already said, like all of the, it sees the things dynamically, it reconciles like other Kubernetes controllers and applies things automatically. And then it has a nice dashboard for getting a holistic view. So it looks something like this. So we can actually monitor what's going on in the cluster underneath. So that's just Traefik .cluster.xx and then my domain. Cool. So now we're soon getting to the demo here, but how do you use Workshop-ctl? So, well, you start with running Workshop-ctl init, then you feed some flags parameters that generate just the YAML file, so you can just generate the YAML file by hand if you want to with some parameters. Then Workshop-ctl gen create, if you said that I want 40 clusters, then it's gonna take these different Helm charts that you have, and it's gonna create 40 different specific instances of these charts. So it's gonna, like, for example, if you have a chart that you wanna automatically deploy with your workshop environment, say you want to set up GitLab automatically inside of your local cluster, then you want to expose GitLab on some URL, and that's why you need to have then 40 different manifest with this GitLab, because the Ingress URL domains are going to be different, and so on and so forth. So it's going to generate a lot of different manifests and then do a git push. Then, but that's just, so now you have all of the manifests that you need. Also the Traefik external-dns code server and the stuff that I was showing earlier. That's all built into the kind of workflow. So you have that automatically. You do git push. Now in GitHub, your infrastructure manifests are now stored per cluster. It's self-sufficient. Then Workshop-ctl apply. In this case, I'm using DigitalOcean, as I mentioned. Workshop-ctl apply creates the, well, essentially, if it's 40 clusters, it makes 40 HTTP REST calls to DigitalOcean's API and says, I want a Kubernetes cluster. And then it doesn't, I'll also say what it does, some other things. It connects with the GitOps workflow that I was talking about with Flux automatically and other goodness. But one very important thing, so at the end of when apply is done executing, then you have 40 unique clusters running your software. Slightly unique, but 95% the same. But the most important thing here probably is Workshop-ctl cleanup, because when you're done with these, it's really a pain. So what I did in the beginning was just go to the UI and click delete, click delete, click delete, and then hope that you didn't forget anything, because then you would pay a lot of money to the provider. So Workshop-ctl cleanup, well, really takes everything you got that was applied and then reverts that. I think that here is a good time to do the live demo. Do we have any questions?
I think in the essence of time, maybe we should get into the demo and then address the questions after.
Yep. So let's start with, oops, that was the wrong. So let's start with the pre-provisioned stuff that I was showing. So here is the code server, cluster.02 workshops.luxuslabs.com in this case. And well, here we have some tutorials that you can use. README. Now I didn't put a lot of a lot in this instead because it was in person. I had slides about how to do these, and then as to show where this is coming from. So Workshop-ctl is hosted here at Cloud Native Nordic's GitHub. And in this case, I just said that in the YAML file that get the tutorials from here, from this Git repo. So you can just specify any Git repo and it will clone from there. Yes, and you have the syntax highlighting because you can install any extension. So this is a YAML extension from Red Hat. The Docker, I think I installed the Docker plugin too, yeah. And yeah, that's really it. You can do in the terminal kubectl get pods. So now I can see that there's different pod info pods that are running here. I was talking about we can also see the code server, external-dns, and Traefik running in the Workshop-ctl namespace. The stuff in the kube system is managed by DigitalOcean. For example, kubeproxy and volume plugins and networking and DNS. And then GitOps toolkit is running here in a GitOps toolkit system. And manages, sorry?
Could you answer how long it would typically take to bring up 40 clusters?
So the best thing is like it takes the same time approximately the same time to bring up 40 clusters as it takes to bring up 5, because it's mostly parallelized. The only thing is like, and now this I didn't check in detail before this. Maybe I should have, but DigitalOcean has some rate limits. So like probably, yeah. So what I should say is, I think that you could create 10 Kubernetes clusters at once, which means that if you do 40, it takes 4 times the time that it takes to do 10. Now that I think about rate limits, but otherwise it just executes the same time it takes to do a couple of clusters, it takes to do more. The only limitation is the provider there and how large quota you also have. So like if you have got a quota that you can create 100 clusters at once, then that's great. Then it doesn't take a long time. Usually maybe from beginning to like from doing Workshop-ctl gen to doing Workshop-ctl apply for like 5 clusters, it takes maybe 5 minutes to bring up them in DigitalOcean, and then maybe 5 to 10 minutes more for DNS to propagate. That is really unpredictable. So maybe I would say 5 to 15. So in 20 minutes you should be without thinking about rate limits. That is per provider and per user. I would say 20 minutes to spin up, say 5 clusters. So it's not a long time, but most of the time it's just for waiting for DNS to propagate, to all users and to your laptops and stuff. So that's the relay takes 90% of the time or something. But it's pretty fast. The point of this is that it's executing fast. And now to see here, I now show the different stuff that is running in the cluster. And if we go to this test workshop-ctl. This repo is what is happening behind the scenes. So now I have 3 clusters here, and the core workshop infra, and this is managed using GitOps. So like, if I would do a pull request or git commit now and change anything in these, it would automatically reconcile. So it's for all of the, so to say, system add-ons, not the user stuff. But again, it was a good point from someone in the audience that you could also pretty easily even you could just create 50 different repos too, and then have every repo connected to the to here. So that is a great idea, and I might just do that. If you contact me afterwards, you can get the credit for the idea.
And I'll pop in a question, 2 questions here. One is, can we share these slides either now or later?
I don't know. Can I just paste things in the chat?
Yeah, you can paste it in the chat, and I'll actually include this in our follow-up email with the recording.
I'll do, yes, I can do it now.
There we go. And then the next question is, are there any cloud providers supported? I'm sorry, are other cloud providers supported, or is it only DigitalOcean at this point?
So at this point, it's only DigitalOcean. I did some tests using, not this one. No, all panelists and attendees. There we go. Can you see it? Should be, yeah, that's a great point. When we have remote lectures in the university, I also prefer if the professor share the slides before, so that if they execute in varying times, you can catch up. So sorry, say that again. So no other than DigitalOcean are supported at this moment, but it's open source. You can just it's a very simple interface to implement. It's literally this. So if you have a cloud provider interface and then just create cluster, delete cluster, that's it. And for the DNS, just clean up and process YAML.
Cool. And try this one. When do you expect to make a first release stable or not? And in the meantime, is it best to just try with the latest commit?
So I have actually everything. So I started with this project a year ago, and then I became really, really busy with school, and I still am. But as part of doing this talk, I was thinking like, yeah, now I'll do a new version. So I would say stay tuned until maybe a couple of hours after this at least. So I didn't have time to do a full-blown release and stuff before this. I have everything in a PR, which you can see is probably the only PR up there on the repo with the latest stuff. But yeah, there's a lot of still things still missing from what you would expect of, like a really full-blown thing. But it's my hobby hobby thing, and yeah. So like if you would like to help maintain this, you are very welcome to do so. If you could see this useful, so part of doing why this is a great thing to talk about in this meetup is looking for people to help maintain it, and also looking for users to actually use it. Because if it's only for myself, then I use it and I update it every time I do a workshop, and now I haven't done any since COVID. But if we have users, then it can be like a more normal flow of like, and other maintainers too. So I can, if there's anyone that wants to help maintain this, I can after this have like private or public Zoom chat calls, and we can figure out what is needed to, like make it really good for also other people than myself. So like obviously there's always some small quirks and stuff, which I think that is, because I've been thinking about this, I think that is obvious or something like that, but it really isn't for one that's using it for the first time. So yeah, so here's the GitOps stuff. If you change anything here, it will be updated. But it is with GitOps Toolkit, you can watch as many, you can watch unlimited Git repos essentially. So you can just this is what you need to do. So if you have a user repo, then you just add this kind Git repository, point it to where their own private Git repository is, and then they have just full GitOps flow. Yes, so that's that. Then let's do the. I'll duplicate this tab, and yeah, if I go to, I can just prove that that the oops. This one. So here is another workshop. So if I change something in here, then it won't be visible in the other one. So that's that. Then let's go to the Traefik UI. So there we go, and we have different. You can play around and look at these things. Here are all the ingresses, services, routers, middlewares, everything, that kind of stuff is visible. And here we now see that this ingress in Kubernetes, which is for pod info, is listed here as one path or one entry point in the browser. Now, going to that, we can see here that this could be a user's own creation and like demo. Now you can see that there's three backend, or there are three backends of this pod, and the front end here, the pod info application, it has millions of knobs and millions of things you can use for demos. But the most simple one is that this front end, which is of this client, which is executing in my browser JavaScript here, is pinging the backend every now and then, and you can see that the one that the pod backend that answers is different every time. So it's load balanced like you would expect with Kubernetes. So yeah, that's that.
And are you aware of other environments like Play with Kubernetes, PWK, Magic Sandbox, MSB? And if so, do you have thoughts about them and how your project compares to them?
I haven't looked at them in a really, really long while. So I'm not that comfortable with saying like a detailed comparison, because I didn't actually check those out. But I think that yeah, maybe I'll pass on that one. And probably if I do a detailed comparison, I'll put in a README. But I think what should be different is like the workflow of like using both GitOps and having this kind of, which I maybe don't have time to talk about here, but I have in the slides here, having like a Unix pipe style generation flow so that we can get maximum flexibility with what kind of applications we install and how we generate them and stuff like that. Really to be able to reuse as much as possible. So for example, here are the charts, the charts built into the application. And the only thing I did to get the pod info running is I just say, get the chart from here and customize, add an override of the values YAML file with this. So put the cluster domain to do that, and have a DNS-ctl of that, and that's it. Then what's generated is at the end of gen, all of this is generated. So there's like which comes from the chart. So it's nothing magic with it, but like this allows for like a greater flexibility in composing different kind from different places, and doing all of that declaratively and in an automated manner. So I think that the scale of like actually focusing on managing multiple different ones is the key thing here. The key thing isn't really, although it's very useful, the key thing isn't like how to create, do the REST API call to DigitalOcean is not the most important part. The most important part is like putting all of the different pieces together so that it actually is a smooth, you just do workshop-ctl gen. I can show the YAML file here for workshop-ctl. So what you would fill in is something like this. So like, what cloud provider am I using? Where is the service account token? What password do I want to have for my for my different for logging in? Now I put the password already, but when logging into VS Code, what do you want to use? Or when logging into Traefik, how many clusters? What DNS provider to use? They can be different. Where to do the GitOps stuff for the infrastructure things, where to get the tutorials from, and what kind of node groups to use, and let's encrypt emails, and what domain to have, stuff like that. So it takes care of the rest. So I'll just finish up in 3 more slides. So because I see we're running out of time here. What have I learned from doing this? Well, it's always DNS, sadly. And propagation times can be really slow, and that can be really frustrating when debugging. For that reason, I'm using actual DNS 01 ACMA challenge instead of HTTP 01. Because the HTTP one relies on Let's Encrypt, on the DNS record propagating to Let's Encrypt, whereas that's actually, and that's more fragile than just like using DNS by default, and then Let's Encrypt is actually prepared for having to wait for the DNS record to propagate. Then you might have to increase your quota. I've hit this a couple of times where there's when I did some workshops in Google Cloud, I needed to increase some random sub-network limit pods per. I don't remember exactly what it was, but it was some really random and super specific quota, which I needed to contact someone to increase in order to to get it bumped, and I had a workshop in a couple of hours, so that was kind of stressful. So actually do a full-blown test before. And sometimes cloud providers have a bad day, so it's good to have a backup plan in terms of like actually supporting more than one provider in this, so that if DigitalOcean has a bad day, or if Google has a bad day, then you can just switch to the other. And here's some just super quick and easy math on what it would cost. It's surprisingly cheap, actually. So say that you have a 4-hour workshop for 40 persons. You create 40 clusters, 1 droplet each. That's $15. And then you have, thanks to Traefik, you can like have, millions of, maybe not millions, but even hundreds of different services that are exposed using their own domain publicly, and still just pay $360. So that, yeah, DigitalOcean doesn't charge for the Kubernetes, so that obviously is a huge plus. And they don't charge for the handling domains either, so that's also great. And then there's some notes about the different prices for the VMs. I think that the 4 vCPU, 8 RAM, and shared has been pretty good and seem to be enough. But obviously, you can increase more if you want. So that's essentially then 4 steps of doing this online. The only thing that I've done all of these except for the second one, but on the other hand, I've done that in school and in other contexts, so it should be doable. So like as long as you have some kind of Slack, Teams, whatever way you can chat with your attendees and actually go to a breakout room and figure out when they have mistyped, some command, or when they have mistyped some YAML indentation. You can do that. Here's a link to like a sample event that we had in Eventbrite for a meetup, and what we wrote in the description there. That it was in person a year ago, but anyways, then curriculum. Here is a sample curriculum, which I have. It's a couple of, I don't know, 100 something slides, and then run workshop-ctl. And full-blown 4-hour video of when we did one workshop in Tampere is there. So that should be it. Any questions? Final questions? So I would have, if I would have had more time, I would have done a like full-blown from the start, running workshop-ctl from the start, and maybe even having a not pre-provisioned cluster by the end of the day, but that would require a bit more than an hour. Just not it wouldn't, while speaking all of this, it would require more than now this hour that we had.
Well, there's no more questions from our side from what I see. So I think we could encourage people to keep their eyes out for this recording, and to contact you on Twitter, and your email is here. They have the slides. But I think you did a wonderful job, and I suppose everyone else here seems to be happy too. So.
Yeah, and it's doing this talk was a kind of a forcing function to get it get a refresher for workshop-ctl, which was great. And yeah, I like to be working with the open source community a lot. So if you think this is interesting, if you think this is a thing that could be interesting to use, although not, being in a stable version or being finished, then yeah, you can go to cloudnativenordics.com is the URL for our common site, and I just happen now, it's just arbitrary that I'm hosting it under Cloud Native Nordics, but it kind of came from here. So we in search, in lack of a better place, we host it under there. their GitHub domain. But yeah, if you go to Cloud Native Nordics, you can find an invite for the Slack workspace. And there we can discuss these kind of things with the people that are interested. And if you would like to help maintain this for the longer or shorter run, then I can help with some one-to-ones. To get that kind of off the ground.
Okay, so I think we can wrap this up now, unless you have something else to say. We'll see everyone online, and the video will be shared in the next few days. Well, several by next week, sometime next week.
Yeah, sounds great.
Thank you, Lucas. Thank you, everyone. We'll go ahead and wrap now. Is that cool, Lucas?
Yes, that's cool.
All right.
See you.
Ciao, ciao.
Bye.